Originally, the gas neck was sticking out of the side of the truck on the passenger side behind the door, but we're moving it to the driver's side rear fender and adding in this custom gas door. So I've marked it and I'm grinding out the Bondo away and I'm cutting it out. I'm going to show this whole process to show that it's not that big a deal. You don't have to get all carried away with tape measures and this, that, and the other thing. Just cut out the hole for the piece to fit into. I'll test fit it a few times and grind the Bondo back away from where the weld's going to be, because I don't want to have the Bondo burning and smoking up my weld. At the front of the gas door, the fiberglass filler is pretty thick there, so I'm going to grind it back and I'm going to put slots in the metal and bend it out to where the new metal is at a much higher spot than it is in the hole. So I'll be bringing the front edge of the new gas door metal outward about 1/8 of an inch, so that there isn't a big Bondo buildup to the little round door. Now I'm trimming it out so that it will be a flush fit. Originally I had planned on overlapping it, but because the Bondo was so thick there, I couldn't do that. I have to adjust this metal outward so that the new piece is out even with the face of that Bondo. I don't have the option to build the new piece up with Bondo because of the opening door. There seems to be some kind of consensus amongst experts that there's something wrong with welding a gap. I have no idea what the thinking is, other than just for me to speculate that these people have never touched a welder, or if they have, they never actually learned how to weld, because I'm going to show you in this process that there's no problem welding a small gap, 1/16, 1/8 inch. It's not a big deal. And in fact, I'm going to show you that it's nothing to it the way we do it. Now I'm going to put the cuts in here that let me bend the metal outward where the new piece will be out level with that fiberglass at the front there. I'll have a little extra welding there at the front corners, but that's okay, no big deal there either. As you can see by the fiberglass filler that's already on it, it's not going to be a big deal to put some more on there. These fenders are 70 years old. They're all beat to crap. No surprise for a work vehicle that's 70 years old. So I have no problem putting more fiberglass filler in it, but I don't want to pile it on there because of that little gas door. I'm going to tack it in a few spots. You see there it's not lined up the top, so I'm pulling it out. Tack it there. But I've got a problem now here at the bottom corner. It won't line up because it's too low. So that's why it's a tack weld. You can break it loose easy. So I just grab it and wiggle it around, and break that bottom weld loose and get it in place. Once I get the thing in place, then I can put more tacks here and there and then start the actual welding. Now, you can see the gap that I've got there at the top is probably 1/16 of an inch. The blade I used to make those relief cuts there in the corners was a 1/16 of an inch blade, so obviously that's a 1/16 of an inch gap. Once I get to welding, then I'm showing you here that that gap doesn't mean anything. It's nothing at all. Just weld right through it. Not even the slightest problem. No slag inclusion, no porosity, none of that dumb crap that these idiots say on my other welding videos. They like to make fun of me for saying that I've been welding for 40 years, as if that doesn't mean anything. But you can trust me when I tell you, when you've been doing something for 40 years, you learn a lot. But there's going to be some ignorant morons that make the comment about how I've been doing it wrong for 40 years. But you'll be able to see in this very video right here that there's absolutely nothing wrong with what I'm doing. I'm getting the job done the way it needs to be done. A strong and solid weld, no big beads sticking up like a MIG weld. That's why I switched from MIG welder to Flexcore. I absolutely hate grinding, and there's a whole lot less grinding involved with Flexcore, even though a bunch of idiots will comment about how it'll take more grinding because they don't have a clue what they're doing. But that doesn't mean I don't want them to comment. I love them comments. Another dumb comment I get a lot of is I should be welding uphill on vertical. For those of you who aren't stupid and are here to learn, Flexcore on sheet metal is difficult to keep from blowing a hole. Whenever you try to go uphill, the weld falls out, and then you got a big mess with a bunch of holes and big blobs of metal falling down. You'll end up with a weld that's as tall as MIG weld. You don't want that. That's a bunch more grinding. As you can see by watching me weld this going downhill, it's super easy. There's nothing to it. This gap's more than a 1/16 of an inch, and I'm having absolutely no trouble welding it together. It's quick, fast, and easy. I'm going to get into much more in-depth instruction on this welding very soon. We know it's just human nature that people get so set in their ways that they don't even want to look at another way of doing things. Grandpa did it this way. School taught me how to do it this way. The book says I should do it this way. The label on the welder says I should do it this way. You can come up with a bunch of different reasons not to try to do anything new, not to try to learn something new. I welded with a MIG welder for 36 years before I touched a Flexcore welder. It wasn't because I didn't want to use a Flexcore welder. It's because I heard all the expert talk of how you couldn't weld sheet metal with a Flexcore welder. And the welders themselves have labels on them showing to set the welder at the lowest setting to weld 18 gauge sheet metal, which is very thick metal. To me, the metal we work with in the auto body shop is generally thinner than 20 gauge. So I was introduced to Flexcore purely by accident. I went to a guy's shop and he said he had a MIG welder and I had a big piece to weld in. Well, when I get there, he's got a MIG welder, but he doesn't have a gas bottle, and he's got Flexcore wire on it. It was a good welder, a Lincoln Power MIG 140, but I had never used Flexcore before, and I was skeptical. But due to not wanting to have to leave and come back, I decided to give it a try. And then 15 minutes into using that Flexcore welder, I converted to a Flexcore welder myself. I no longer use a MIG welder for anything. See no point in it. I consider the only con to using Flexcore is the spatter and the smoke. neither of which are a deal breaker. I can weld in a windy shop. I have a lot less bead to grind, less heat transfer into the metal, and that's another one that the experts will poo-poo on because they're setting their settings on the Flexcore way too low. I'm setting my settings high. The settings I'm using for 22 gauge steel is what they're saying should be used for 1/8" plate. When that wire touches that sheet metal, I'm getting instantaneous fusion, 100% penetration, no excess buildup in the form of a bead like with a MIG welder, no false pretty weld that has poor penetration like with an inexperienced MIG welder. With Flexcore, you have to learn how to weld or else you just blow holes. I forgot to mention that there's a fan blowing right on me, right across where I'm welding, and that's causing me no problems at all. Whereas if I was using a MIG welder with gas, I couldn't have that fan blowing on me, and I would be very hot and sweaty. And I like to stay cool if I can, so being able to have a fan blowing on me is such a big plus that I can almost say that's the number one reason, although it's not. Now, if you've been watching the weld, you can see I'm not slowing down. I'm just welding. But if I were to be welding a piece into straight metal that wasn't all beat up like this fender, I would take my time and go a little slower and move around, put a stitch here and a stitch there and back and forth and around and give it a little time in between so I wouldn't build up much heat. But in this case, the metal is already warped to crap from being beat up, so a different warp here or there is not going to make any difference. I'll take my stud welder and pull out any low spots around this that might have popped in from heat getting the warpage going or whatever. Now I'm running into the spot where the fiberglass filler is too close to the weld and it's catching on fire, so that smoke gets up in there and messes with my weld, and so I'm going to stop and grind it here in a second because I'll get tired of the fire. And that brings to mind another thing about Flexcore that is far superior to MIG when we're working on an old car. And some of you might know this already, like when you have rusty pitted metal, it's not rusted all the way through, but there's some deep pits in it that you take a wire brush to it and they become little holes. The metal's not completely rotted out, but it's got a bunch of like craters in it that are real thin in the middle. Well, you can take a Flexcore welder and weld those holes up in that rusty metal. You can forget about it with the MIG welder. I've tried it and it ain't happening. It just falls out. So to recap the advantages of Flexcore over a MIG welder in auto body is A, you don't have to worry about being in a still air environment. You can have air blowing around, whether it's a windy shop or a fan blowing on you to keep you cool. It's not going to cause porosity in the sheet metal like a wind blowing away your gas does on a MIG welder. Next is the bead height. As I said, I weld at a much higher amperage than what the experts recommend, and I get instantaneous fusion with flat bead. It's not sticking way up like a MIG welder bead, and much easier to grind since it's not sticking up so far. Much less heat transfer. Doing the instantaneous stitch welding and moving around and coming back to spots, and instead of trying to run a continuous bead, keeps from building up a bunch of heat in your surrounding metal, so you get less warpage. No dealing with the cost and the logistics of going to get gas and running out of gas in the middle of your weld and stuff like that. Of course, you have to keep an extra spool of wire on hand because you run out of wire with a Flexcore welder just like you would with a MIG welder, so keep your extra spool of wire ready, but you don't have to worry about going to get gas and stuff like that, and it's just an added expense that you don't need. If you don't need something, why buy it? I'm proving to you right here that you don't need any gas. No gas at all. There's no reason to have gas unless it's Taco Tuesday. Now I'm grinding these welds down. I've got a fairly wore out roll-lock disc, but it's working okay, and I don't have that much of a bead to grind down, so it's not a very big deal anyway. After a little bit of grinding it down, then I'll go back and weld any little holes that I might see, and then do the final grinding on it, and I'll be done. Even though this roll-lock disc is wore down a lot, it's a Cubitron disc, which is very long lasting, so it does a pretty good job even when it's wore down. Since this panel was all beat up, I don't need to grind it down any further than this, since I have to put a lot of fiberglass filler on it. So please touch my like thingy and subscribe, damn it!